Let's work on some of our definitions for the different kinds of matter that we'll be talking about. Now you can see here that we're going to be talking about all matter at the very beginning, and we're going to create a bit of a flowchart that helps us handle the definitions. The first question we have to ask ourselves: when I'm looking at my object, is it made up entirely of one kind of particle? And when we say particle, we could be talking about molecules or atoms, anything like that. So if it was absolutely pure water, water would be the particle. If we're talking about hydrogen gas, the hydrogen gas would be the particle. If we're talking about hydrogen atoms, specifically things that are torn apart in just atoms, then we'd be talking about hydrogen atoms. So we're talking about all the different types of particles at the same time right now. Now, if they are all the same, this is going to be a pure substance, and all of the examples I just gave a moment ago were pure substances. Next question we have to ask ourselves: are they all going to be one type of atom? So is it purely hydrogen? Now, if it's hydrogen molecules, sure, it's still going to be purely hydrogen. It's a pure substance, and in that condition, it's going to be an element. You can see right here. Oops. Here we are. Now, if it has multiple elements present inside, like hydrogen and water inside of pure water, then it's going to be called a compound. So an element, another example of that would be a pure gold bar. For a compound, a good example of that's going to be pure water. What if we do have more than one type of particle present? Well, then it's going to be some sort of a mixture. The next question we have to ask ourselves is this uniform throughout? If the answer is yes, it's going to be a homogeneous mixture. Now, a homogeneous mixture, the example I'm giving of what that would be like would be Kool-Aid. You're going to have the flavor compounds, you're going to have the red dye compounds. All of these different things are going to be floating around, and you're also going to have the water molecules themselves and probably some sugar molecules. However, you aren't going to have single spots where you're going to find all the red dye. You're not going to find all of the sugar molecules in just one spot either. That's going to be uniform throughout. Now, if it's a heterogeneous mixture, that'd be something like wet sand, where you do have spots that are just silicon dioxide, the sand. You're going to have spots that are just water molecules, and that's going to be a heterogeneous mixture. So these four endgame terms are the ones you really need to be able to distinguish: element, compound, homogeneous mixture, and heterogeneous mixture.